Welcome to episode 12 of the Norton Nemeses 1500cc V8 rebuild. And in this episode, I am making a new oil distribution pipe for the gearbox, fitting the alternator and grinding in the valves. Oil is sent to the gearbox from the high pressure gallery into these 2 points here, one above each bearing. The oil then flows along the gearbox shaft to lubricate the gears. I'm going to be using the original drilling in the high pressure gallery and shape the copper pipe to fit neatly behind the alternator. The original pipe was actually an old brake hose, hydraulic brake hose with different colour flange ends, which wasn't very pretty on the engine, so I decided to make a new one-piece manifold from copper and brass. Also, with the alternator now being fitted, I can't reuse these old pipes because they hit the bottom of the alternator. I had a rummage around in my shed and managed to find a piece of 6mm bore copper and some stainless steel brake fittings. These banjo bolts are ideal, so I can machine them down from 10mm to 8mm to fit the engine. The first thing I need to do is grip the banjo bolt in my 3-jaw chuck on its hexagonal head, with the thread protruding. Then I can machine away the existing 10mm thread until I reach a diameter of 8mm. With the last of the thread machined away, I check the diameter just to make sure. It should be around 8.5mm. We're aiming for 8. With the diameter measured, I put on the last cut. With the diameter finished, I'm now ready to cut the thread, so I apply a bit of oil, use my standard die wrench with an 8mm die and the Jacob's chuck to hold it square. After a couple of turns, I remove the banjo bolt from the chuck, put it in the vise. This is stainless steel, it's really hard to cut. This is much easier in the vise. There we go. I've now got a nice 8mm banjo bolt that should screw into the engine. Just perfect. I'm really pleased with that. I now repeat the process for the second bolt, and then we're ready to start making the pipe. To do this, I've used an old brake hose, cut off the banjo fitting off the end, so I can machine down and drill a hole to braze onto the copper pipe. The first thing I'm going to do is put the fitting in the vise and file the end square. I can now transfer the flange to my toolmaker's vise to drill the hole larger so the copper pipe just slides in nicely. That's just perfect. So now we can do the other one. I drill the hole right through on this one because it's a middle fitting. Pipe comes in both sides. I look outside, it's absolutely pouring down the rain. This is a perfect day for working inside. I trial fit the banjos onto the engine so I can cut the copper pipe to the correct length. With the pipe cut to length, I remove the sharp edges with a file and deburr the centre hole with a drill. I then use a bit of steel wool to clean the copper to remove all the oxide coating. With the parts all clean, I'll trial fit the pipe back onto the engine, ready to make the front pipe. The copper pipe is quite malleable and I'm able to bend it around my thumb to get the correct shape that I need. And here it is taking shape. Just need to bend this down now and cut it off to length. With the pipe cut to length and deburred, I trial fit it back on the engine and it fits just perfect. So now we're ready for silver soldering joints. I'm using a high silver content silver solder with a flux coating on the outside to make it easy to use. When the metal turns cherry red, it just flows nicely into the joint, making a nice seal. And here's the finished pipe. After it's cooled down, I give it a nice clean with a steel wool and blow it out of an airline to make sure there's nothing inside the actual pipe itself. Then it's ready for a last fit back on the engine. Before I refit the pipe to the engine, I need to restrict the flow of oil that flows down the pipe into the gearbox. To do this, I silver solder up the large hole in the banjo bolts and then drill it out with a smaller drill. I can now refit the pipe to the engine, and I'm really pleased how it turns out. It looks a lot nicer. I look outside and the rain stopped, and there's a pigeon in a tree looking down at the ground, and I realise he's looking at his friend, who thinks he's a duck, sitting in the water. Very strange. I can now fit the alternator with its new gear, but first I remove the metal cover off the back to relocate the wire because it came out at the top near the exhaust manifold, which is not ideal. I was able to reroute the wire so it exits at the rear of the alternator and then put a rubber grommet to protect the wire. I left the original grommet in place to make a seal to stop water getting in. With a bit of sealant applied to the sealing area, I offer up the alternator to the engine and gently slide it in, engaging the teeth. It's a bit of a fiddly job, but I get there in the end. With the alternator finally slid in place, I put in the 3 bolts and do up tight. As a final check, I rotate the crankshaft backwards and forwards a little bit, observing the shaft of the alternator, and I can see movement, so that's good. So now I can put the wire end through the grommet and feed it out through the back of the engine, away from the hot exhaust. I'm really pleased how the alternator installation turned out. It fits really neat on the back of the engine and clears all major systems. Even Charlie Weaver's impressed, and he had to pour himself a drink. The next thing to fit is the starter motor. This slots into a hole on the left-hand side of the engine and is secured in place with 2 screws. It's a bit of a tight fit getting the O-ring to engage, so I have to gently tap it with my rubber mallet. With the starter motor secured in place, the next thing to fit is the drive gear and the starter clutch assembly. The starter clutch is held in place with a big flat washer and a special countersunk screw. I initially fit this, but then remove it and fit a more substantial 13mm cap head with a nut, so I can use that for turning the engine over when I'm doing the cam timing. That's better. The 13mm spanner easily turned the engine backwards and forwards now. I look outside and the pigeon's still sitting there in the drinking water. It's been there for ages. The next job to do is grinding the 32 valves into the cylinder head. I pre-cleaned all the components a while back. I'm going to be using my valve spring compressor, suction cup and vintage grinding paste. The valve seats look pretty good to me, so I'm only going to be using the fine grinding paste initially to see how I get on. If that works, that's all I need to use. With a thin smear of grinding paste on the valve, I gently insert the valve into the valve guide, press it down tight onto the cylinder head, then use my suction cap to rotate it backwards and forwards by gently applying some downward force to grind the valve in. This can take some time. After a few minutes grinding, I remove the valve and have a look, and it's got a nice grey finish all the way around, so that's just perfect. The valve seat also looks good, so that's 1 done, 31 to go. With the last valve done, I clean the cylinder head up and valves with some brake cleaner. All the valves and their associated parts are numbered in a box so I can put them back into the same place in the cylinder head. This way it should maintain the original tappet clearances. I expect the tappet clearance may have changed a little bit because I ground the valves in, but not much. So first of all, I put a drop of oil on the valve seating area, wipe it around my finger and smear a bit up the stem as well, just to make it slide in nicely. With the first valve fitted, I can now fit the 2 valve springs, one small one and one big one, and the retainer. These 2 little collets hold the retainer in place, but to get them in I have to first compress the valve spring with the valve spring compressor. This can sometimes be a fiddly job. You just need to drop the collets in and hope they seat nicely. And as you release the spring pressure from the valve spring compressor, they should pop into place nicely. Well, that's the first valve installed. Just got to repeat the process 31 times now to fit all the valves. Well, that's the first 16 valves fitted into the first head, so now I can get on with the second one. I'm quite pleased how it's turned out, it looks really nice. With the second head completed, I can now start fitting the shims and the buckets. The shims sit on top of the valve in a little recess, and then the buckets slide down over the top. With all the shims and buckets fitted, the heads are now basically complete, ready for fitting the camshafts and doing the valve clearances. Fitting all the valves and springs is quite a lengthy job, but it's worth it in the end. It looks so nice, and Charlie Weaver was so impressed he had to pour himself a drink. He's had quite a few drinks today. I can hear some noise going on in the kitchen, so I go to see what's going on, and Tracy's making a banana cake. This is just perfect for using up whole bananas. So first she mushes up the bananas into a bowl with a fork, making them all nice and smooth and consistent. Then cuts up a bit of butter and puts it into the food mixer with a bit of sugar, whizzes that round for a few minutes until it's all nice and smooth. Then she adds a couple of eggs, followed by a dash of vanilla essence. This makes the cake taste extra nice. And then some flour. She spoons the flour in after weighing it on the scales, then adds a bit of baking powder. Then she mixes the ingredients at full power for a couple of minutes and adds the bananas. With all the banana mix added, she then whisks it up even further until it's a nice creamy consistency, pours it into a baking tin, and then puts it straight in the oven for about 50 minutes. While the cake's cooking, I go back into the garage and fit the camshafts. I'm going to temporarily fit the camshafts into the heads so I can check the clearances before I fit the heads to the engine. The camshafts are held in place with several bearing caps that are numbered to match up with numbers on the cylinder head. It's really important that they return to their original position. The camshafts have a hexagon that allows you to use a spanner to rotate them freely. This is really useful when setting up the shim clearances and rotating the camshafts when the cylinder head's off the engine. With the exhaust camshaft fitted, I can now proceed to tighten up all the screws holding the inlet camshaft in place, gradually a bit at a time to pull the camshaft down, because as you do up the screws you're compressing the valve springs and opening the valves. To prevent the valves hitting the bench, the cylinder head's resting on two pieces of wood to lift it off the surface. With both the camshafts fitted, I can now start checking the valve clearances. So to do this, I use a spanner to rotate the camshaft to get the lobes pointing upwards on two of the corresponding valves, then check with a feeler gauge for the clearance. I slide the feeler gauge in between the camshaft lobe and the bucket, and it's a nice sliding fit, so that's just perfect. I now use the spanner to rotate the camshaft around to the next pair of lobes pointing upright, and check the clearances with the feeler gauge, and these are also good. After checking all the valves, I only had a couple out of spec, so what you do, you note down the size of the clearance you've got, and when you need to take the camshafts out, remove the buckets, remove the shim, you measure the shim and fit a slightly thicker or slightly thinner shim in to get the correct clearance. And that's the job done. So the next thing I need to do is fit the drive gears to the camshaft into the cylinder head. The Nemesis V8 engine has gear-driven camshafts rather than the conventional chain-driven or belt-driven. So I start to assemble the gears into the cylinder head by first putting some grease on the bearing surfaces and on the inside track to hold the needle roller bearings in place. It's quite a fiddly job. You've got to engage the gear with all the bearing and shims up inside the head and put a pivot shaft through the outside without pinching anything. With the first gear assembled, I tip the cylinder head up on its end, balance it on a piece of wood to hold it secure, and I can gradually slide the gear in, making sure I don't knock the shim off each side until it lines up with a hole in the centre. I then put on a bit of grease and carefully slide in the shaft, engaging with the shim and bearing. It's critical at this stage that you feel it in nicely, and you feel it hit the bottom without any pressure at all. If it's slightly raised proud, the shim's not engaged properly and it could get damaged. When I'm happy it's okay, I do up the two securing screws. With the two screws tightened, the last thing I do is spin the gear and check that it runs freely, which it does, so I'm really pleased with that. And then I hear a shout from the kitchen, the cake's ready, it's all cooled down, and Tracy's sprinkled on some lovely icing on top as well, like drizzled it on to make it look nice, makes it taste better as well. So we sit down in the dining room, have a nice cup of tea, and a piece of freshly made banana cake. It was so nice. Well, thanks for watching. I hope you enjoyed it, and I'll see you all soon in the next video.